So in this chapter, we wrap up our conversion queue server-side code and implement some additional functionality before we move on to the client implementation. We start by retrieving the results of our conversions from the server. We demonstrate how to handle zip file upload for assemblies, and then we deal with Amazon S3 storage. And at the very end, we talk a little bit more about additional scalability considerations and using mongoDB Atlas for storing our queue. Okay, let's dive into the code. So before we implement the code for file download, we need to make one more change. Right now, if a new cut model is put on the conversion queue, it gets immediately processed. And if a lot of cut models are getting added in short interval, that means a lot of simultaneous conversion might be going on the same machine. That eventually will, of course, bog down the system, or in the worst case, can lead to the computer running out of memory. To prevent that, we will write code that limits the maximum amount of cut conversions that can go on at the same time on a single machine. There's two new variables here, the sim conversions, which is a counter, and then max conversions, which is the maximum number of allowed conversions, which is currently set to 4. And now in that get conversion job from queue function, all we need to do is check if the sim conversions counter is below that max conversions limit. And if not, we just simply don't process the queue. And of course, whenever we are pulling a new job from the queue, we incrementing the sim conversions counter. And if a cut conversion is completed, we are decrementing it in both cases, either if it's an error or if the cut conversion is completed successfully. Then let's also enter that max conversions as a configuration setting. So we have to pass it into that start function. And we're adding that value to the configuration file as well. And finally, we are passing it in when the queue is created. Also, one more final improvement as we are already here. We only really need to start that web server if we are actually running the server as well. Okay, after this is out of the way, let's now implement our additional API calls for retrieving data from our conversion server. So we start with a function that just gets some data about the converted cut file. After the endpoint has been created, we then implement the necessary code in the controller as well, basically by pulling that information out of that server module. And we're returning that as a JSON object. And now for the implementation of the getData function in the server module, which should be pretty straightforward. Just a bit of boilerplate code here. Yeah, passing in the item ID, and then we're just getting the item, the conversion item from mongoDB by passing in that item ID. And if we found something, we're just gonna return a slightly sanitized version of that object. And if we couldn't find that object for some reason, maybe because of the wrong item ID has been passed in, we're just returning an empty JSON object here. To test out our new API endpoint, we turn back to Postman, specify the API we want to use, and then we're retrieving the item ID from MongoDB's Compass. We have it here. We just copy and paste that in. And now if we press send, we get the properties of that conversion item returned. Okay, let's implement the even more important functions that retrieve the SCS and image files from the server. Just calling them SCS and PNG here. And instead of get data, we are now returning getting SCS and PNG. Really keeping it very simple here from an API perspective. So now let's move on to the implementation of those endpoints in the controller. Copy and pasting get data, changing the name. And then in the function itself, we are calling this new server function that we still have to write that retrieves an array buffer containing the SCS data. And we're gonna turn that into a blob with this function here, and then returning that in this call. And we're going to do exactly the same thing for the PNG data. The next step is to write these functions in the server module. We copy and paste from get data, get SCS, same process. We find the correct conversion item based on the item ID, and then we pull the binary data out of storage with the correct path. And then we do a little copy and paste magic and do the same for PNG files. Before we move on to the zip upload, just a little bit of housekeeping. When we pull a new item from the queue, we should actually change its status so that in case the server crashes, we know that something has happened and the thing has already been processed, or at least there has been an attempt made to process it. And so we do that here. Every time a new item is pulled on the queue, we are changing its status to processing. So let's move on to zip conversion. And the motivation for that, just to recap, is very simple. Sometimes cat files consist of more than one file. That could be a complex cat assembly, like a CATIA model, for example, but could also be a GLTF file, which oftentimes has a binary file and then some additional texture folders. We could take different approaches here. We could convert each cat file one by one and have then a final API call that performs the conversion. But to just keep things simple, we are using the zip file approach. So the user basically zips up its cut model into one zip file and then uploads that zip file to the server. So in order to implement this in the function that processes a conversion queue, we are checking if a zip file has been uploaded. And if that is the case, we're just calling a different function that unzips the file first and then runs converter instead of running converter directly. And in this new function run zip, we first assemble the correct directory, again for our temp file. And then we write the code that actually reads the zip file and unzips it. So we're creating a read stream here with that directory and the correct item, and then we pipe that through this new unzipper npm package. And if we are done, we are getting a callback that we then have to act on. And if everything has worked correctly, we send out a little console message, and then we run converter as usual. We have to make a slight change in that function, but we're doing that a little bit later. Of course, we might also run into an error. And in that case, we are printing out the error to the console, and we just clean up our directory. What we also want to do in this error case here is write out the error message into our database. Only in this case, it's like a zip error. And we need to decrement our sim conversions counter as well. Finally, let's install that new unzipper package and make sure to include it into the module. One problem that remains is that a zip file, of course, can contain a lot of different files, and we don't really know which cat file we should convert. In some cases, we could probably guess what the correct start assembly would be, but that's not always possible. So to keep things simple, we just let the user decide by passing in the correct start path. So for that, we start by adding a new entry into our conversion item schema, which will contain our optional start path. And we're going to retrieve that start path in the API call for the file upload. It is basically a new property on the body. And we'll see how that looks in Postman shortly. And we need to add that start path here when we create the new database item for the conversion item. In case if it's undefined, nothing will be added here. And now for the code in run converter, we create this new input path because we now have two different cases. We either have a zip file that has a start path. If that's not the case, then we just use the normal path to the file. And if there is a start path specified, if it is a zip file for all intents and purposes, then we are retrieving that file from this zip directory. And of course the start path that has been specified before. So in order to try this out, we are going into the offering converter example data folder in the package and use the microengine model. That model is an assembly consisting of a bunch of part files and one cut assembly file. So we are zipping it up and then uploading it to our server. We also need to find the correct start path, and we do that by going into that folder, finding the cut assembly that we actually want to convert, and getting its path. Now we're creating this new start path item in the body and pasting the path to the assembly. Of course, we are only interested in the relative path here. And we're hitting send on the request, but there were a few small errors that we can take a look at here. We have to, that is actually a string, and we also need to make sure that the directory is actually added here to the item. And that dot was also a typo. And let's send that request again. And now, if we look at the console, we see that the microengine has already been unzipped. The conversion was successful, and we see in permanent storage we now have the zip file as well as the PNG and SCS. Okay, let's move on to implement storage in Amazon S3. And for that, we start off by creating a new module, which is basically permanent storage S3, which is equivalent of permanent storage file system that we wrote before. For now, we just copy the basic scaffolding of the file system implementation, delete most of the contents of the function, and then start with our own implementation. Before we do anything else, let's install the AWS SDK. And we are pulling it in with a little bit of boilerplate code here. Then it's time to initialize AWS, and here we need to actually provide the access and secret key that AWS requires to work. There's different ways to pass that in, but one way, the easiest way to do it for the sample, is to just provide it in a separate file. And this is how that file looks, and of course you have to provide your own access and secret key at this point. You're also not really defining a directory here, but an Amazon S3 bucket, and that's something we're also going to pass in from the configuration. Okay, let's implement that store function, and what this does is basically reading the file just like it did in the file system, and then it saves it into S3, and we have to obviously write a function that does that. Now onto that store in S3 function. Because the AWS SDK does not work with promises in its current form, we're actually creating our own promise here where we wrap everything in so we can nicely use that, that function in an asynchronous call. Now we need to specify the S3 specific upload parameters, which is the bucket we are planning to use, as well as the key for the file, which corresponds to the relative path. And then of course the data itself. And as I said, for the key, we're going to use storage path, and for the body, the data. And then we call the upload function, which takes these parameters. And again, as a callback, and for now, if there's an error, we just send a console message out. Advanced error handling is definitely not something we focused on in this course. We leave that a little bit up to the user. So if things are correct, we basically send out a little console message that the data has been stored in S3, and then we're solving the promise. Now we quickly write an analogous function that reads a file from S3. Again, it's very similar. Again, we're creating a promise here. Then we're setting up the correct parameters. And we're calling the function to get the object from S3. And if everything has worked as expected, we are returning the body. In the configuration file now, we are adding a setting if we want to use S3, setting that true for now, and we also provide the name of the bucket we want to use. And of course, we need to add these settings into the toStart function for the conversion queue and the server. So in this case, if we have S3, our storage module that will be used is this S3 storage, and otherwise it's going to be the file system storage. And we do the exact same thing in the conversion queue with a little copy and paste. And just a bit of formatting to make it all look nice. And of course, we can't forget to pass these two settings on to the conversion queue and the server. And fix a minor typo in conversion queue and server. There was another typo. We used the wrong settings name. And we also need to make sure that conversion data is all lowercase. And there's one little error to correct at the very end. We need to make sure that we are loading the AWS credentials from the file that we created previously before we actually initialize the S3 library. Okay, let's go back to Postman and rerun our REST call. Data sent up to S3. We got the microengine zip file sent to S3. Conversion was successful, and both the SES and PAG also end up in S3. And now if you actually switch to your Amazon S3 console and look at the bucket where you uploaded the files, you will see, with a little bit of reloading, that everything is in the right place. We have this conversion data folder. In there we have a single file uploaded consisting of three things: the zip file, the PNG, and the SCS. Great. So by using S3, we've come a long way in making our conversion queue more scalable. Now all files that are up for conversion, as well as all the results of the conversion, are all in a centralized location that can be accessed essentially from anywhere. That is not automatically the case with the conversion queue and the database in general, though. So if you have another server, it will have its own database and its own queue. In order to change that, you could, of course, provision your own mongoDB server that all the other conversion clients connect to. That requires, of course, a little bit of extra infrastructure. So one way to avoid this, in particular for this simple example here, is to use mongoDB Atlas. MongoDB Atlas is essentially MongoDB in the cloud, and you can sign up for it. It's free for development and light use, and without making any additional changes, just by changing the MongoDB UI, essentially, you have one centralized location for all your database information. That basically means, in combination with S3, you have a scalable solution now where all the data is in one place. Okay, that concludes this chapter. Let's move on to the client implementation.